hey, so I'm Shashank, I'm a PM on the AKS team. I work specifically on the multi-cluster and service mesh areas, and also worked in the past on the ARC areas as well, and extending AKS beyond the cloud is another topic that's very close to my heart. And today I'm excited to talk about all of these topics. So yes, today we'll talk about fleet management. We'll talk about extending AKS beyond the cloud, and we're going to talk about roadmap of these areas as well. So packed agenda ahead of us. So let's start with fleet. What is fleet? All of us know about AKS. We've been hearing about AKS since morning. Fleet, there have been a few mentions, but what is fleet? So before we get into the product part of it, fleet in general is referring to a group of some objects. In this case, we are referring to a group or a collection of Kubernetes clusters. How is this relevant? I think, this is what now the 7th KubeCon, or how I have lost count now, the 7th year. And we have been talking about Kubernetes, and a lot of these large organizations have a lot of Kubernetes clusters, right? It's not one or two. There are quite a lot of customers, so quite a lot of platform teams who have a few hundred clusters and so on as well. Now, for them, these platform teams, it brings with this a bunch of challenges in terms of how do you set up those clusters, how do you manage those clusters in terms of scaling them, upgrading them, and so on. Now, with respect to all of these collection of clusters, that's where fleet comes in, and we want to sort of simplify the experience for these platform admins to be able to manage them and set them up, but then also for the application teams that they cater to, for them to be able to consume this platform in a easier way. So that's how we are thinking about fleet from a direction and area perspective. Within the scenarios, there are two set of scenarios that we can think of. One, when you have hundreds of clusters, there are a certain set of challenges where it's just too many number of interactions that you have to deal with for each of these clusters, and it becomes a scale challenge, right? Setting up a monitoring policy to setting up of access control for the clusters. So that's one set of challenges. Second, there are also a set of challenges in terms of, let's take the example of cross-cluster communication. You need to set up things where, in the lack of a grouping construct, you are doing that setup yourself. And a grouping construct, and for us to be able to help with that setup of service discovery, for example, would make life much easier there. So that's how we are looking at fleet. Fleet at a very high level is just a group of collection of clusters, and how this fits in from a product perspective we'll explore in the rest of the deck. Now, why have multiple clusters in the first place? During the lunch session, I got a very good question on how do you think about multi-tenancy versus multiple clusters, right? And we were discussing a few of the reasons there too. Why have multiple clusters? We have seen platform teams have multiple clusters for resiliency. They just don't want to put everything onto a single cluster and be dependent on it. And if something goes wrong, or some configuration was done wrong, they don't want the whole set of services to be brought down. So for resiliency is one. Second, for scaling in terms of not running into subscription limits or running into the limitations of a single cluster, we have expanded on the scale for a single cluster quite a lot from the AKS perspective itself. But having said that, Kubernetes upstream also always has had limitations in terms of how big a single cluster can scale. So if we are talking about platforms who are running 100,000 pods to couple of thousands of services for that platform, single cluster may not be even possible for those kind of platforms. Next, just for the reason of having testing, staging, and prod, not everything is directly deployed to prod. People want to first deploy it into their earlier stages, gain confidence, and even in terms of orchestrating upgrades, they just want to do that first for the earlier set of environments and then bring it onto prod. Next, having clusters in different regions. Now, this could be for the reason of data resiliency. They could also want to have clusters in different regions, from a disaster recovery standpoint, a cluster in a paired region. Next, cluster as a tenancy for better isolation itself. Now, there are two schools of thoughts, right? You can definitely go for the multi-tenancy route where you can have namespaces act as a virtual isolation. There are like more things that we are doing as well, which we spoke of earlier in the day in terms of the isolation related experiences. But when we are looking at multi-cluster itself as a unit of isolation, so it's a stronger like form of isolation, right? Like your clusters are itself separate over there, and what you connect them in terms of whether it is cross-cluster communication or not is completely up to you. So a higher degree of isolation, and we have seen like a few platforms opt for cluster-level multi-tenancy. And next, clusters in different clouds. Multi-cloud is a reality. Hybrid cloud is a reality too. So we have seen few folks do that, and like with respect to those non-Azure and non-AKS clusters, we've all like Azure has a strong set of experiences in the form of Arc-enabled Kubernetes and things available on top of that. So these are a few of the places where we have seen like platform teams want to have like multiple clusters. What challenges does this create? I already spoke about a few of them. Cluster management, dealing with lifecycle management, the upgrades, minor version, patch version, node images, keeping them all consistent, having consistent configuration across all of these clusters. These are one set of challenges. Then when it comes to deploying the same set of application, when I'm looking at a platform, right? I'm not deploying a single application into a single cluster, but I'm like trying to deploy maybe the same set of services across multiple clusters. Now that brings with it its own set of challenges. How do I set up service-to-service like communication, for example? Second, how do I set up authorization policies for that? How do I set up like TLS encryption for that? How do I set up telemetry for that? So there are a whole bunch of those challenges. And then second, like it's not just deploying them, but also how do I like write my SLO like queries and so on against those services that are deployed across those clusters, right? So there are a whole bunch of challenges with running these apps across these multiple clusters as well. Next, so far we have been talking about the context and the problems that like sort of necessitate people moving towards multi-cluster. Now let's start taking a look at like, okay, what are the scenarios and how these scenarios kind of play out in the product and how you can set it up. In terms of scenarios, one, even before we talk about the Kubernetes Fleet Manager as a product, we've always had like at-scale scenarios, and there are a lot of management plane kind of experiences that Azure provides to simplify these at-scale scenarios. For instance, with respect to RBAC, it's as easy as going to the IAM blade of the clusters. You have Azure RBAC for AKS clusters. You have Azure RBAC for Arc-enabled Kubernetes clusters as well. And that RBAC is not just specific to the Azure control plane. Sure, you can like completely like granularly control the actions that are done on the Azure control plane, but at the same time, you can also control the data actions as well on the data plane, like right to the level of like who has permissions to create a deployment or custom resource definition. All of those can be controlled. Next, Azure Monitor for like Azure Monitor Container Insights. We already spoke a lot like earlier during the day about like container insights, and then managed Prometheus, managed Grafana. All of these experiences, they're available for both like AKS and for Arc, and like we have like a centralized dashboard experience. So if you go to the Azure portal, like just search Monitor, like and then enter through there, and like click on containers, you'll get to see the list of like all the monitored like clusters, AKS and Arc-enabled Kubernetes. Same like extending this to policy. So Azure Policy is available as well for like AKS and Arc. So it's not just like having Azure Policy sort of like help us out with like the policy enforcement on the ARM related changes, but also for data plane as well. We have gatekeepers sitting inside the cluster doing the in-cluster enforcement of the policies that you've declared. And all of these apply like across the board at scale for AKS clusters and R clusters, and you have like a centralized dashboard kind of an experience where you can view the policies that have been applied, but also like view violations of those policies and where you're able to audit all of them. Next, just a high-level view of how Fleet Manager sort of fits into this whole picture and like how this at-scale experience looks like. So I briefly spoke about a few of these at-scale experiences in the third like square over there, the identity, security, auth, and the RBAC part. Now, like in addition to those, we also have like a top level like product and offering itself called Azure Kubernetes Fleet Manager, which allows you to like group clusters. Its sole purpose is to allow you to group clusters. It's a simple, lightweight resource. You can like go to Azure portal, like click on Fleet, like just fill in the same set of like inputs as an AKS cluster, and like within like 2 minutes you'll have the fleet created. And how is Fleet helping out from a scenario perspective? That grouping of the clusters that it helps with, where you can group any cluster within the same Azure entered like tenant, like you can group clusters in different subscriptions, you can group different clusters in different regions. And then once that grouping construct exists, you can then do things on top. You can like propagate Kubernetes configuration across clusters where you can say, hey, like I want to target only these clusters with certain matching constraints. You can set up multi-cluster load balancing for distributing your traffic across multiple clusters. You can do cluster lifecycle management where you can orchestrate the updates from one cluster to another in a proper sequentially defined manner, and also at the same time have consistency. So a whole bunch of these things, we're making them available on top of this grouping construct, and we're using that grouping construct to sort of simplify the whole setup experience, because in the absence of that, you're doing a lot of like heavy lifting yourself, which we kind of like want to simplify. And we do get a question about, hey, how does this like relate to GitOps? Like, how is like Fleet related to GitOps? Are they one and the same? Like, do we expect a like unified experience? Yes, I think like, of course, we are like invested in the unified experience as well. And GitOps works seamlessly with Fleet. So you can have the Flux GitOps agent, pull in your configurations from like any Git source as usual, and then just point them to the hub cluster. And from the hub cluster, we already have the capability to propagate these configurations down to the member clusters, along with the additional like filtering capabilities like, hey, I only want to propagate to this like cluster with matching constraints. So you get the best of both worlds. You get a smarter hub orchestrator, which is able to like take in your rules and then place that said workload against the matching clusters, but you also get the benefit of GitOps in the form of Flux being able to pull down all of these like configurations from Git, and then being able to apply them down to Hub, and then Hub applies them down to member clusters. So you get the best of both worlds. So that's how we see those fitting together, and that addresses one of the common questions that we get. Okay, now let's enough of talk about scenarios and everything. Let's walk through some like actual like use cases, and then also see a few demos as well. I have like two set of like experiences. We'll go through them one by one. Jack, he's a lead for a platform team managing hundreds of clusters. He's responsible for ensuring the clusters are all up to date, consistent, and they're all like optimally optimized. So at the first part, like we're going to talk about the multi-cluster updates and node image consistencies. So why is lifecycle management a problem? One, Jack is operating hundreds of clusters. He's not operating one or two, but hundreds of clusters, and these clusters are there in different regions. Now, why does it take like 3 to 4 weeks for them to upgrade? One, because like so many clusters also means that there are like minor versions available once in every 4 months. There are patch versions available whenever there are security updates. And when you're like upgrading these hundreds of clusters, like it does take a bit of time. And especially when you have like legacy applications, we've seen that platform teams kind of like hesitate to upgrade at a much faster clip, but rather they slow down and they update like once in a blue moon, right? So how can we help like this kind of a platform operator out? Like how do we meet them where they are? So we like sort of made available multi-cluster updates on top of Fleet, wherein you can group the clusters, you can like bunch these clusters into stages, define your wait times, but then also get the guarantee of node image consistency as well. So when an update run starts, you like could have clusters in different regions, but we will figure out, hey, what is the latest common node image available across all of these clusters? And then we start picking that node image to upgrade all of these clusters and their node pools, and we ensure that there is consistency across the board. And for that, like, yeah, the whole thing starts with like Fleet, lightweight grouping of resources. One thing that I want to announce like as new, when we started out with Fleet, like late last year, we always had an hub cluster, and like if we think about like multi-cluster updates, right? The hub cluster was not a requirement as such. So to make it even simpler and Fleet even more lightweight, we now no longer have the hub cluster with the Fleet resource if you don't need it. So by default, we just create the Fleet without the hub, and it takes like almost less than a minute to create that Fleet resource itself. And it's just a lightweight grouping construct itself. So if you don't want the hub, like you don't have to use it. And if you do have a need to use the scenarios, for instance, workload orchestration and like load balancing, only then you can go for the hub cluster. That's totally fine. And the joining of the member clusters remains the same. Anything within the same tenant, you can join them. For the demo, like, I have like a bunch of like member clusters that have been joined to Fleet over here. You can see the list of the member clusters over here. And we have introduced another new capability wherein if you go to the Fleet overview blade, you'll now get a centralized dashboard which will talk about how many member clusters do I have, what is their version distribution, like Kubernetes version, like what is their minor, like patch version distribution across the entire like Fleet, and then what is the node image that I have across the entire node pool. So this aggregated like dashboard view, which we previously did not have, now we do have, and you can use this as sort of like a notification hub, and then from there like go and start your update runs when you see that, hey, like I'm like lagging behind on my versions and my updates. I had a question over here, like, so. Multiple clusters. I'll just take that in a few minutes. I'm like currently covering the lifecycle management part. When I come to the workload orchestration and the placement part, I'll like revisit that question and I'll tackle that. Yeah. Fleet multi-cluster update, as we were speaking about it. So there are a few concepts that we need to be aware of: update group, update stage, update run, and update strategy. Nothing complex. We'll have a like diagram and like a demo as well, like in a minute. Update group is simply a group of clusters for whom the upgrades are done sequentially one after the other. Update stage, it's a collection of groups. The upgrades are happening in parallel. And within a stage, you can define like a wait time between the stages. So let's say you have a staging stage and a prod stage. You can say that, hey, like after staging is done, like wait for a day or two. Like it gives you time to monitor that everything is fine, and then like move on to the prod. Update run, think of it as a flowchart. In an update run, you have stages. Inside stages, you have like groups. It's as simple as that. And then update strategy is just a way of storing your update runs for like future instances. So it's a stored template for update runs. So if you want to create an update run once again, you can just reference the strategy that you already have and say that, hey, I want to create this update run with the exact same ordering of stages and groups. So it's a time saver. So how does this look like? Yeah, the flowchart looks like this. You have update stages. Within the update stages, you can define the wait times. And then within the update stages, you can like compose the different groups, and you can have the ordering over there. Now, like where is this helping out? So as I said, from a upgrade frequency perspective, we have like minor once every 4 months, patch more often, node image updates. So if you are following AKS release notes, which we highly recommend, we have node image updates every week. And it's always recommended to stay like on the latest like node images. So like how is this kind of like becoming a challenge like for a few of the users who have legacy apps? So if the legacy apps aren't ready for seamless restarts, they take a lot of time to upgrade, and that needs to be a planned activity, and like to make sure that the environment is consistent across the entire collection of clusters. When you have hundreds of them, that becomes a problem. So there, how is Fleet helping out in those kind of environments? So we are introducing a new feature now wherein inside of an update run, you can just specify that I want consistent node image across my entire update run, and we'll just pick out the latest common node image and then apply that across the board. Demo, 1 second. Let me exit out of this view. 1 second. Let me, okay. I need to show portal. Meanwhile, I'll take the question because it's coming up in the next section. So the question was, if you have an application of 10 replicas, how do you spread that out across multiple clusters? So we have this concept of a cluster resource placement, wherein you can have a configuration and then have the same configuration applied across multiple clusters. So you can say that, hey, for this particular cluster, I want you can have let's say 3 replicas and then have that 3 replicas configuration deployment spread across 3 clusters, so that way it becomes 9. And then in the future roadmap, we also have plans for override, wherein you can have cluster-specific overrides to control the total number of replicas and so on. And in future, we also have plans for metrics-based scheduling as well, wherein based upon the total number of resources available in the cluster, we then schedule the cluster to the cluster with the highest amount of resources available and so on. We have a very active set of things coming up in the community as well around that. Please hold on. After the demo, we'll come back to that. I have that. Yeah, I have to go to portal.
Yeah, so you have to go to your screen settings. If you go up to your Apple, we just have to change your display settings.
Oh, okay. Let me. 1 second.
Yeah.
Okay.
And then we go to
display.
Yes. And sorry, it's hard to see with the lights right now. Sorry. There we go.
Okay. Yes. So for demo, so this is how the create experience for a fleet looks like. It's very straightforward. You just need to type in the same set of inputs as the AKS cluster. So we are creating a cluster without, so a fleet resource without the hub cluster. I wanted to emphasize on how simple of an experience this is, and hence the live demo itself. Yeah, you can here if you want add member clusters right now, but you can add member clusters later too. And member clusters is as simple as I can click on add and choose a bunch of AKS clusters that I have access to. But for now, I'll just create the fleet resource and member clusters we can add later. Now we go to review and create, and yeah, validation passed. And we click on create, and in a minute or so, it should get created. Meanwhile, what I'll do is I'll go to a fleet resource that already exists while it creates, and show you a few things in terms of how the multi-cluster update run experience looks like. So this is the overview dashboard that I was speaking of. It gives you a distribution of the actual cluster versions, the node images, the total number of update runs that are running, and so on. Now, speaking of the update runs itself, you can go over here. You'll see the update runs that have ran. So this was a run that I had created earlier in the day. So you can see stage 1, stage 2, and then you have group 1, group 2, and it completed. And for this one, the upgrade wasn't necessary, so it was skipped. And it'll show you when were the upgrades done, how many minutes did it pause for, what stage did it complete, all of those it will show. So if I go back one level over here, so if you click on create an update run, here you get to define the stages and all of those experiences. You have the option of stages if you want a sequential ordering, or if you have the option of one by one. Here, if you want consistent image, it's as simple as a click over here. That's about it. And if you want to already use an existing strategy, instead of creating a run with stages from scratch, you can just click on copy from existing strategy. Here, it has 2 stages sequentially ordered, so you can just choose them and create the run. So earlier in the day, I had just created a run with that, and this was the result that you saw over there. Meanwhile, I think, yeah, the fleet deployment succeeded. It took less than a minute. So no hub cluster if you don't need it as of now. And if we see over here, we should have the fleet resource ready. And you can just start adding your member clusters, removing them, grouping them. The whole experience is fully simplified. So this was the multi-cluster update run experience. 1 second. Next, let's go for deploying application across multiple clusters and setting up traffic. So here I was speaking a little earlier about cluster resource placement. So this is the resource that I was referring to. So you can declare a cluster affinity in terms of like labels and selectors. Here we're choosing clusters only which are present in the East US region and deploying like against them. But you can also have like more advanced like placement like constructs as well. So right now, like in a week, we are introducing topology spread constraints, the ability to pick n clusters out of the superset of clusters. So all of those like advanced scheduling capabilities, you can expect to see them land like in the next week or so. And we also have a, it's not just that we are developing all of these by ourselves, but we are happy to announce that like all of this, especially the agent and the workload placement part, we are open sourcing as well. So this will be on GitHub. So you're free to like come and engage with us, contribute over there. And we see more and more number of customers reaching out to us about, hey, Kubernetes internally like has a take on topology spread constraints, has a take on how to schedule the application across like within the cluster, but across the clusters that doesn't exist like a unifying project right now. So yes, please feel free to come and contribute and like engage with us over there. An active set of discussions happening on this particular topic right now. Next, north-south load balancing. Similar to a single cluster, except that the load balancer is now like load balancing traffic across endpoints in multiple cluster. So you can have like a multi-cluster service for whom that specification like I've shown on the screen there. So you can just have it like load balance traffic across the endpoints on multiple clusters. As of now, this requires the clusters to be on a continuous network, so either on a flat network or on peered networks, and overlays on our roadmap. And as of now, we have an L4 load balancer available for multi-cluster load balancing, but you would have heard earlier in the day about app gateway for containers being in public preview. Now that's for single clusters as of today, but we have it in our roadmap like first half of next year to also work on multi-cluster app gateway for containers, L7 load balancing across endpoints and multiple clusters. So that's on load balancing. Now let's quickly check a demo. For this, I do have a demo video over here. So let me go into screen mode and let me play. Yep. So here I was starting out with creation of a cluster, but we already saw the creation of cluster short demo. So let me just skip ahead a little bit. So Fleet has now been created. Now we will like have a demo of the workload placement as well as the load balancing part. So you see that the Fleet resource has 3 member clusters. Here, what we are doing is we are like assigning the role, we're creating the role assignment to give us the permissions to be able to deploy to the Fleet resource. And then we are going to fetch the kubeconfig for the Fleet resource. So just like you do AZ AKS get credentials, here the only difference is that it's AZ Fleet get credentials. It's the exact same command. It fetches the kubeconfig. Now we are ready to talk to the hub cluster. Now, the hub cluster you'll need to talk to only for like workload placement and load balancing. Now, let's actually get into the hub cluster and like inspect the member clusters. So you'll see that there are 3 member clusters out there, and you'll be able to see their statuses as well. Now, going to the actual objects that are getting deployed. So we are creating a namespace, a demo namespace, demo deployment, demo service, and then we are creating a service export. So what is this achieving? So it's creating a simple like hello world kind of like a deployment on top of each of these clusters, and then the service export that you saw at the end is responsible for exporting this service endpoints across all the clusters and to the hub so that the multi-cluster load balancing can be done. Now we are looking at cluster resource placement. This is the custom resource which allows for matching against a cluster with a certain set of constraints. So here we are matching against clusters which are from the East US region, but the new set of like releases that I mentioned like allows you to do like far more advanced things in terms of topology spread constraints and so on. Now we are going to apply this cluster resource placement on top of the Fleet resource, and that basically is an indication for Fleet to say, hey, like pick out all the applicable resources and match them against the, like place them against the target clusters. We are going to apply that cluster resource placement now. Oh, 1 second. Yeah, we are going to apply the cluster resource placement. And we see that the demo namespace, the deployment, the services, all of them got deployed. onto the member clusters. And we are now using the kube config for each of the member clusters. Member cluster 1, member cluster 2 got those configurations as well because both of those clusters were in the East US region. Member cluster 3 did not get that configuration because it was not in the East US region. So that CRP only propagated to the clusters in the matching constraints there. Now we'll set up the load balancing part. So we're going into multi-cluster service, and then we're defining that I want the traffic load balanced across multiple clusters. And then what this does is it gives me a single external IP that I can hit, and that load balances traffic against all my internal endpoints. Now we are sending traffic one by one to that public load balancer endpoint, and we see that if we look at the address field, the red part, right? We see addresses 24, 15, 23, 15, 24, 23, 24, and so on. Now we are going to check where these addresses were coming from in the next step. So we are getting the pods from member cluster 1, member cluster 2, where these apps were deployed. We see that 15 and 17 were from member cluster 1, and 23 and 24 were from member cluster 2. So effectively what is happening is you just have a single endpoint in front of multiple clusters, a public endpoint that you're hitting, and that's load balancing traffic across multiple clusters, and it's a single service for all practical purposes. So this was a demo. Next, our feature roadmap for Fleet, how is it looking like? In the upgrade area, we have auto triggers and planned maintenance up next. L7 load balancing already spoke of. L4 is there, L7 is on its way. Multi-cluster service mesh, so we have single cluster Istio add-on right now. Multi-cluster integration with Fleet and supporting different CNI modes isn't there yet, but that's something on our roadmap for the next year. Next, we have identity federation. If you're setting up identity federation, there are limits in terms of the total number of FICs that you can create and so on. So this feature is set to address those limits. Next, we have Arc-enabled Kubernetes clusters and member clusters. So today we only support AKS. In future, we will support Arc-enabled clusters and member clusters as well. Speaking of non-AKS clusters, let's extend AKS beyond the cloud. So Jill needs to maintain a collection of clusters across Azure as well as their hybrid environment. So we are now going to talk about AKS hybrid and how it allows us to extend to the hybrid environments and multi-cloud environments. And now we get into, the cloud native anywhere part. So here you can see a layered set of approaches. So we have always had Azure control plane as a single unifying control plane across Azure resources as well as non-Azure resources, and Arc is kind of that conduit to bring the non-Azure resources into the visibility of Azure control plane. And once the resource representation exists, that's when you can layer on top of that multiple scenarios in terms of data services, for instance SQL MI, or you can have app services or management services Azure Monitor, Azure Policy, all of these, whatever services you are used to in the Azure world, you can uniformly apply them to your non-Azure resources as well via Azure Arc. And it's not just the layer on top, but for your hybrid environments, we have AKS hybrid itself. So you can have AKS on Azure Stack HCI. You can have AKS on even light edge devices as well. So you see those three lights over there, like a device over there. That's actually an AKS on edge device over there. So those are 3 nodes, a single AKS cluster. We can manage the lifecycle of that cluster via portal. You can deploy things on top of that via Azure Arc, GitOps. You can have Azure Monitor, Azure Policy, all of those deployed on top. So imagine that $500 device, 8 GB RAM. So you can basically have that in industries. You can have that on your factory floor. You can have that on your cruises. So basically you can have these kind of devices propagated everywhere, and then bring them into the fold of Azure and just have remote management, remote deployment capabilities and so on. And next, scenarios. Yeah, it's the same set of scenarios as AKS. We want to have that perfect consistency. So I want to create a cluster from ADO pipeline. I want to use Terraform to deploy my clusters. I want to have the same experience with respect to Entra in terms of the role assignment. I want to have the similar kind of diagnosability that I'm accustomed to with AKS. So these are the scenarios that we are envisioning with AKS everywhere. Now, speaking of the AKS hybrid, so what things are new with the AKS on Azure Stack HCI 23H2. So now you can provision and manage on-prem AKS hybrid clusters from Azure itself. So what that means is that you can go to Azure portal. So just like AKS is managed cluster, these clusters are provision clusters. So you can just go to Azure portal, click on Kubernetes clusters under Azure Stack HCI, and then you have a simple experience to create these clusters. We'll see a demo very shortly. In terms of CLI as well, it's nearly identical. So the only two differences you see is AZ AKS hybrid create instead of AZ AKS create. And the second difference is that you will see a custom location parameter over there. So think of this as being a site. So you can have a set of you can have Azure Stack HCI set up in a particular place, and you can say that, hey, I want my custom location to point to that, and I want my AKS edge cluster sitting on top of that. Next, we have the creation of the AKS cluster on HCI 23H2. We have a demo of that as well. So here we are just showing how it's just another custom location entry, but everything else, the inputs and the experience remains the same. Let's see a quick demo of that.
Hi, I am happy to demonstrate the customer scenarios of AKS on HCI 2309 preview. There are a few typical tasks customers can follow to validate the end-to-end user experience. The task 0 is to deploy the Azure Stack HCI cluster. Starting from 2309 preview, AKS infra will by default included with HCI 23H2 build. Once the HCI deployment completes, customer should be able to create AKS cluster without additional infra installation steps. We will skip this step of HCI deployment but focusing on target AKS cluster related operations. So right after that there will be 3 tasks to go through. We will show how to create the AKS on HCI via Azure CLI and Portal. Then some new integrated portal experience with HCI. Finally, we will leverage the newly created cluster to demonstrate the approach of deploying a sample Kubernetes app. Now let's start the cluster creation in Azure CLI. In this preview version, there are 2 manual workarounds need to be performed on HCI hosts to prepare AKS creation, including create AKS VNet and download AKS VHD. These 2 steps happens on hosts should be removed and improved in the next release. Once complete some necessary preparation, we can start the creation of your first AKS cluster on HCI with CLI. In preview 2309, only smart default provisioning is supported. Some of the typical selections like the AKS version 1.24.11 is the default and the only version supported, and the default node size is standard Kubernetes v3, etc. So, in this script there will not be such parameter as they are using default value. After input necessary parameters, includes VLAN ID, the custom location ID, the resource group, AAD group ID. The provisioning will be kicked off, and it will take a few minutes to complete. Now the provision completes. It will output a JSON format of the AKS cluster properties, and you can see provisioning status is succeed. Now let's see what's the experience on Azure Portal. We will show the newly introduced workflows of linking the AKS hybrid cluster to its belonged HCI cluster. It includes view prerequisite status to create AKS hybrid, hybrid clusters associated to HCI cluster. We need to find the target HCI cluster from the list. This is the HCI cluster we are looking for, and we can see there are a tile in getting started and indicate the prerequisites check passed. We can get into the details. There are a few steps include the one we just finished for VNet creation. You can also see there is a new link starting available to track all the AKS cluster under this HCI deployment. By clicking on the cluster, you can see the details. You can create a cluster from here as well. The creation experience will be the same as the way you start within AKS or Arc AKS tabs. In this page there are some basic inputs. If you have many HCI clusters, you need to get the custom locations mapping to the right one. And as mentioned before, there is only on Kubernetes version supported in 2309 and it cannot be changed. There are also the primary node size type and SSH keys. We also changed the control plan node size. For authentication, we choose the Microsoft Entra and select a Microsoft Entra group we pre-created. The pre-created VNet is available here to select. Also the configure of load balancer, leaving other 2 tabs as default with no changes. The validation will take a while. Once the validation passed, start the AKS cluster creation process. In a few moments, the creation completed. You can get into the resource group and find the AKS cluster just created. There will be a link help you connect back to the belonged HCI cluster. Now let's try to deploy a sample app to the cluster we just created and a Redis instance in the cluster. The very first command downloads the kubeconfig of your AKS hybrid cluster to your local machine and opens a proxy connection channel to your on-premises AKS hybrid cluster. The channel is open for as long as this command is running. We will keep this session running and connect to your AKS hybrid cluster from a different terminal. Verify that you can connect to your
I'll pause the last part of the demo. So basically what we're doing is once the AKS cluster is created, it's the same consistent experience that you're used to, right, for creating AKS cluster. So we're just getting the kubeconfig for that cluster the exact same way, except that you're running a proxy command, because we have to do it through the cluster connect channel, it's in a secure way. And once you have that proxy command run, you can start executing the same kubectl command. So you can do kubectl apply, delete. It's pretty much the exact same experience there. And you can deploy whatever applications you're deploying to AKS. It's the same things that you can deploy there, and it's a consistent experience. So this was the demo for AKS on Azure Stack HCI. Next, it's not just, I want to emphasize on one last point with respect to the AKS Edge experience. It's not just the technical or the feature side of things, but also we offer the same kind of support as well. So you're used to if something goes wrong in the AKS experience, you're used to the first-class troubleshooting experiences, diagnosability experiences. So with AKS HCI, we provide the same. And so if some issue goes wrong with respect to the supported components, you can create a support case, and Microsoft is helping you out as well. And remote support, it allows Microsoft to collaborate with the customers to obtain access in a secure way to help the customers diagnose what's going wrong with their permission. Next, we added these 2 slides at the end on request after we got a few questions on multi-cluster service mesh during the launch. So basically, one, we already have single cluster Istio service mesh add-on, as I already spoke of. What challenges we heard from users, hey, orchestrating Istio upgrades on top of clusters is tough. Fine-tuning Istio for large-scale clusters is again tough. You have to fine-tune code DNS and a whole bunch of other things. Hooking up Istio with Prometheus, Grafana, and other things takes a lot of manual steps. And then we also need to have compatibility between Istio and the underlying AKS version. Who does that? So those were a few of the challenges that we heard from the customers. And why AKS Istio add-on was introduced was, one, we want to have Istio versions tested against the AKS version. That's something that we do. Second, we handle the scaling and the configuration. We set up the Istio add-on for high availability and so on. Next, we also set it up the core DNS for large-scale clusters and fine-tune it to be able to handle the large number of requests. And then we also have external internal ingress already available. And in terms of the metrics and the observability experience, it's very easy. You can deploy the managed Prometheus experience in the exact same way as you do for AKS, and then you just need to have one scrape config, and then all the metrics are there. And we also, of course, provide official Azure support for the add-on as well. This is how the service mesh looks like. It's again the same classic Istio control plane, and you have the sidecar proxy model right now. At the same time, we are also taking keeping an eye on the ambient project status. It's right now alpha, and at the right point of time when it becomes beta and stable, we would incorporate that as well. This is another common question that we get, so addressing it in advance. So I'll have a short one screen to show for Istio, and then after that, just one more last point. Yeah. So one Second. This is a peek into what we are releasing. So this is actually not yet released, but tying it back to Fleet. So if we go to portal, if we go to the service mesh, Istio, you'll see a blade over here. So we are developing Istio like experiences as well over here. And if we do 30 minutes, you'll see that like there are a whole, like I had deployed a sample app, I generated like traffic for this. Oh, I'd still, my God, I was showing the deck itself. Yeah, so this is the tab that I was speaking of. We are introducing a Istio like service mesh tab. So this is not yet released, but it's going to be released in the next 1 to 2 weeks. So you'll see like we are populating the metrics, the core metrics for request per second, error rate, latency, and so on. So why is this important? We spoke about setting up SLOs for services and across multiple clusters. This is the first step in that direction. We are starting off with these metrics, like getting them in place and in the portal for your single cluster in Istio. The next steps are getting Istio working for multi-cluster, and then also like on top of these metrics, providing an experience for authoring your SLOs, your burn rate, and all of those. And then from there, like hooking it up with the rest of the Azure monitor and alerting infra for setting up your alerts. So this is the vision that we have for like service mesh and multi-cluster and as a whole. So the message that I would like to conclude with is, it's for the central platform teams, we are kind of meeting you where we know that it is a reality. We are meeting you where you are, and we want to help like sort of simplify that operator experience for you. And another question that we got during the lunch break, and like this for all the AKS topics, not just for Fleet, but there were a lot of questions on, hey, like where can I check out these demos? Like where are these videos and so on? So we have recently introduced the AKS community YouTube channel. So please do check it out. And second, please do stay tuned on the AKS repo on GitHub. We don't yet have an index of all of those demos from the AKS YouTube channel, but given the feedback that we got like earlier in the day, we are going to like publish the index of all of those demos on the AKS repo. So stay tuned. We have a lot of good stuff coming up.